Manuna madam, shall we start?
Okay.
We are live
Yes.
on Facebook as well.
Yeah. Good afternoon, Digvijoy sir. Good afternoon.
Good afternoon. Sir, shall we start?
Yes. And okay. Let's start.
Shweta madam.
Yes, sir. Thank you so much, Digvijoy sir. Good afternoon to one and all present here. Thank you for joining with us today. I'm Assistant Professor Shweta Agrawat. On behalf of ITM BU family, I'd like to welcome you all to this international symposium on directions in research. And today's topic of discussion is building chatbot using deep learning approach. And to begin the session, I would like to welcome our eminent speaker, Professor Dr. Bui Thang Hung, Director of Data Analytics and AI Lab, Director of Information and System Program, Engineering and Technology Faculty, Thu Dao Mott University. Sir has received his MS and PhD degree from Japan Advanced Institute of Science and Technology. Sir has completed 2 projects, published 4 journals, 6 book chapters, 21 international conference papers, and 13 domestic conference papers. Sir had received 2 Best Paper Awards of FICTA 2018 and RICE in 2020, and he is selected as Excellent Scientific Researcher of Thu Dao Mott University in 2019 and 20 as well. He is a reviewer of many journals and conferences. He is also a keynote speaker of many domestic conferences of Saigon University, Thu Dao Mott University, Industrial University of Ho Chi Minh City, Nguyen Tat Thanh University, as well as of foreign conferences of North Orissa University, India, SIRT India, Indore Institute of Science and Technology, India, VNS Group of Institutions, India, Manipal University, India, and Japan Bangladesh Robotics and Advanced Technology Research Center, Japan. His main research interests are natural language processing, machine learning, machine translation, text processing, data analytics, computer vision, and artificial intelligence. So without further ado, now I would invite Professor Hung to start the talk. Over to you, sir.
Thank you for your introduction. Today, I would like to present with you about my topic, building chatbot using deep learning approach. Here is an outline of my presentation. First, I will talk about natural language processing. Next is the deep learning and how to build chatbot using deep learning approach. After that, I will give some experiment from my research. And lastly, I will give conclusion. Now let's start with the natural language processing. What is the natural language processing, NLP? You know that natural language processing, it means that it's the process information contained in the natural language text, and also known as computational linguistics, human language technology, natural language engineering. Yes. And natural language processing is one important artificial intelligence, which in the natural language processing, there are many tasks, but we talk about the linguistics, with the work tokenize, lexical analysis, syntax, semantic, and discard analysis. For example, here is dependency parsing. We have the raw sentence, and from raw sentence, we will get the part of speech jumping. And from that, we can build the work dependency parse sentence. Dependency tree here, we build from the dependency we get. And sometimes we use this semantic parsing. Here is some example of semantic parsing. and a Descartes analysis. And from natural language processing, you know that with the related to the text where we had a lot of work, and from the a lot of work we can build a backup work or dictionary, and from the backup work we can build one hot vector. For example, here is the re-sentence, and from the re-sentence you can tokenize to the work, and you can use the backup work as well as one hot vector. And and
Hang sir, kindly unmute yourself. I had to mute all the participants. Thank you.
okay, and here is n-gram. For example, we have this sentence. It means that we have 1 gram here, and here is 2 gram. And the last example about the 3 gram here. GF IDF here one important picture in the natural language processing. It means that GF means that term frequency, and IDF means that inverse document frequency. And GF IDF we can calculate by the formula as shown in this slide. And the last technical about the natural language processing related to work embedding. GF IDF is an important picture. However, it's not describe the relation between the work, and so that work embedding technical is very good technique for the natural language processing. In the work embedding, we have many kind of work embedding. For example, Symposium or Skigram, proposed by Thomas Nicolet et al. 2013. And here is about the Symposium from the Thomas Nicolet et al. 2013. And from the one hot vector, we can use the neutron, look like the neutron network. We can build we can build to find the work embedding for work. And Skigram is a research with the Symposium. And another work embedding technique here, you can see that Glovo, fast text or BERT. Glovo from the Stanford MIT research group, and fast text from the Facebook AI research, and BERT from the Google AI. And here is the number of citations when I check with this term. The model, the BERT architecture, you can see that in this slide, from the pre-training and deep bidirectional transform for language understanding. And in the natural language processing, there are many tasks. In the last column, you can see that it are related to the linguistic. And the second column, you can see that is some natural language processing tasks. For example, information retrieval, information extraction, name entity recognition, sentiment analysis, work send, and this by.
I'm sorry, sir. I'm interrupting in between. It would be really good for us if you could go a little bit slower.
Slow. Okay.
Thank you, sir.
Thank you. And co-reference resolution or Discord analysis. And in the third column, you can see some advanced natural language processing. For example, machine translation, automatic summarization, natural language generation, question answering system, dialogue system, and email captioner is some advanced natural language processing here related to chatbot we talked today. However, natural language processing is difficult. Why is it difficult? Because you know that language is ambiguous, and language is flexible, language is subtle, and language is complex. And there are many hidden variables, and we had to face with the problem of scale, problem of the sparsity, and long-range correlation. That's why LNP is more difficult. And the key problem here is we have to representing a meaning and language pre-suppose knowledge about the world, and it reflects the survey of the meaning, and it presuppose communication between the people, so that we need the natural language processing in the many tasks. Uh, in the as a talk about the natural language processing, and what is the thought in the natural language processing. Next part, I will talk about the deep learning and how to deep learning to how to use deep learning to solve the problem of natural language processing. You know that machine learning is one main approach for the artificial intelligence, and deep learning the main approach of machine learning. What is machine learning? Uh, the definition by Tom Mitchell, he says that a computer program is said to learn from exponent E with respect to some class of task T and performance measure P. Is performance at task in T as measured by P and improved with the pre-experiment E, is a definition from the Tom Mitchell. For example, if we look at the flying checker, T means that's the start of flying checker, and E means that the experiment of playing many game of checker, and P means that the probability that program win the next game. And how about the recognizing the cat? T here is as a task of identifying cat in the picture, and E means that the experiment of looking at a lot of cat picture, and P means that probability that program will detect a cat in the picture. We can divide machine learning to three groups. The first group is supervised learning. The second is unsupervised learning, and the third group is reinforcement learning. And another group is a mix between unsupervised and semi-supervised. We call it is semi-supervised learning. How about your artificial neural network? You know that about the here the biology of neuron, biology of neuron, yes. And with the biology here and here the artificial neural network. In the picture A, you can see that in the human neuron. In the picture B, is the artificial neuron are hidden immunity. And in the picture C, the biological synapse. And the last picture, ANN synapse. And when we zoom in the one neural network, you see that we have the input and the cell body here, and we have the activation function, synapse here. And the network chaining is mean that is the process of changing the connection weight and threshold of neuron based on learning pattern to satisfy certain condition. It's a neuron chaining. And in the neuron chaining, backpropagation is a very important process. This process that to update the weight. For example, here the one way to update the weight with the weight is from the pre-wired neuron, and N it means that learning rate, and GT means that the current gradient. And you can see that the backpropagation here is a neural network. And how about the deep learning? Deep learning built from the neural network. And machine learning very different with deep learning. You can see that the difference between machine learning and deep learning in this picture. In the machine learning, we do picture extraction and classification separately. However, in the deep learning, it's the same process. And there are some difference between the deep learning and machine learning. With the data, we need the big data for the deep learning. Require machine learning machine with the GPU and strong computer, and maybe it take a long time and difficult to data interpretation. And here is the scientist that got the Turing Award in last year. This look like the Nobel Award for the computer science. We don't have the Nobel Award for the computer science. We only have the Turing Award. And they published the Deep Learning International in 2015. And when I check it in the last month, which is a very large number of citations. And it's the same, we can divide the deep learning is the same with the machine learning. It means that we have three groups: supervised deep learning, deep reinforcement learning, and deep unsupervised learning. And combined between deep supervised learning and deep unsupervised, we have the deep semi-supervised learning. And here is some deep supervised learning, FNN, CNN, INN, LSTM by LSTM. Here is a recurrent neural network, RNN, in the supervised learning. It means that we have the gate here, and from the gate we can remember or forget the last step or the last picture for the next step or the next step. However, if we had a long process, it's more difficult. That's why a long short-term memory was born. It was proposed by Hochschild and Schmidhuber in 1997. And the long short-term memory with the 4 gate here, you know that the RNN there is only 1 gate in the long short-term memory. It has 4 gate. And from 4 gate, for example, if we zoom in at T, you see that the at T means that the previous layer input with the previous state here, with the bias here. And from forget, we can remember or forget the picture or the result in the last step for the next step. LSTM by LSTM is composed from the 2 LSTM with the forward and backward LSTM. When we combining forward LSTM and backward LSTM, we had a bidirectional LSTM. How about the CNN, convolutional neural network? This model proposed by Fukushima in 1980 and improved by Likun, Boto, Benjo, and Hartner in 1998. In the CNN, there are 3 main layers. The first is convolution layer, the second is a Markov link, and the last is fully connected. What is the convolution? We had picture, for example, we had picture. From the picture, if we apply the convolution with the kernel here, we can average this, and we get the result here. It means that in the convolution layer, we will resize the image to smaller. However, smaller image keep the main important picture from the last image or original image. And the second is the Markov link. For example, with the picture with the size 99 here, we have kernel here. There is 3. We can resize the picture to 7. And Markov link is it means that we apply the kernel, and by there are many pooling, Markov link or average pooling. Here is a Markov link. It means that the Mark value in the kernel, yes. So that from the picture with 7, we can resize the picture to the 4, look like so in this slide. And the next is the value is for overfitting. It means that we can keep the negative, positive number and change the negative number to 0. Yes. And negative fully connected. It means that we will plot the last result to the only 1 column. And from that, we can use to predict the original picture is XRO by the probability. Yeah, it is fully about the CNN. We can apply comparison relu or fully kinetic many times. Yes. And there are some famous CNN model, for example, LeNet, AlexNet, GGG, Google LeNet, RedNet. These are own famous model here from the ILSBRC contest. Here is the roadmap of the CNN. Yes, from Likun, CNN, LeNet, AlexNet. Yes. And how about reinforcement learning? Deep reinforcement learning. First, we have to understand reinforcement learning first. Reinforcement learning is mean that we have agent, environment, and reward and state. And we can take action here. And what is different? What is deep reinforcement learning? Here is reinforcement learning, and here is a deep reinforcement learning. It means that we apply neural network for the reinforcement learning. Yes, you can see more detail, more clearly in this picture. And in the deep learning, we use the attending mechanic. This is proposed by Madano et al. 2014. It means that if we keep the own picture, it's more take a long time for the processing. However, we can forget or focus on the important picture. We can save the time for the processing, the attention mechanics. And another model is the transformer model. This proposed by Vaswani et al. 2017. And another is variation on how to encode the VAE. A third group, deep unsupervised learning, with some famous model here. For example, generative adversarial network or graph neural network. Okay. So now we know about the machine learning and deep learning and what is different between the machine learning and some famous model in the deep learning. And next part, I will talk how to use deep learning to build the chatbot. You know about the message. Here is a picture described about messaging app, and you will see that every day there are 1,000 or the million or billion messages all over the world. Here is a statistic about some application, WhatsApp, Messenger, WeChat. Yes, and the AI with the talk natural language processing is the main important in the artificial intelligence. And what is chatbot? Chatbot is means that is an automated system designed to initiate a conversation with human user or other chatbot. And there are a lot of chatbots here. But here is an example of chatbot. You see, why we use chatbot? Because you know that the chatbot, if we use a chatbot, we can say the cost, and it's online. It's immune to shed, boredom, and sickness, and it doesn't misbehave and handle multi or million consumer simultaneously and reply in natural language. And it's no need to install an additional application and very fast response time. That's why we need the chatbot. And how about the history of chatbot? From the 1950, we had the Alan Turing. Yes, we had Turing test. And 1965, Eliza is the first chatbot. And the 1972, Paris. Yes. And 1990 with Lobner, Alice to 1995, and Mitsuku in 2010, 2013, sorry. And here is why a certain is applied to chatbot with some famous company, technology company, for example, Siri from the Apple, Google with the Google Assistant, Amazon with Alexa, Microsoft with Cortana. And we can apply to build the chatbot by two approaches. The first is retrieval-based model, and the second generative model. And we can apply deep learning model to build the chatbot. The most famous model we use here is the LSTM sequence-to-sequence model. Is often used in machine learning, and we can apply GFIDF. And here there's some algorithm we use to build the chatbot, and you see that there are a lot of deep learning algorithm here with the long short term, deep neural network, recurrent language model, yes, work together, yes. And here is a sequence-to-sequence model architecture. It from the paper building end-to-end dialogue system using generative hierarchical neural network model. And one example here is a mini chat sequence from the Ming Hu et al. It's published in ACL 2017. They apply in information retrieval model, which applies sequence-to-sequence. And how about the Microsoft CLC? Here is the architecture of Microsoft CLC. You can see that, and the core function here is natural language processing, and I only talk about the natural language processing, not talk about how to not talk about technical hardware or something like that. I only focus on natural language processing here. And in this chatbot, they use you can see here INN, how to generate the question and answer from using the INN algorithm, INN deep learning model. Yes. And the Siri work. Siri is a very famous Apple. And here is how Siri works. The picture from Jerome Belagara. And next, I will share with you some experiment. The first experiment is my research in a Vietnamese question classification based on deep learning for education support system. It's published on 19 International Symposium on Communication and Information Technology. And as a talk that we can apply two approaches. The first is information retrieval, and the second is generative model. And in the research, I apply in the information retrieval. Here is the architecture of our proposed model. We apply by question classification. It means that we collect the question, and each question we have the answer for each question. And like when the customer input the question, we will use the natural language processing. Here is we use work embedding and by LSTM algorithm to classify the question. And when we have the result, we will give the answer for this question. Yes, it means that the question
Vedi.
from the data we pre-processing, we apply work embedding. Here we use the fast tag from the Facebook AI research, and we apply it in by LSTM, and we build the application here. And here is example of our application. Uh, we apply for the educational support system in our school. And however, in Vietnamese, there are a lot of duration. And however, the people usually the forgot or the miss the duration. And in this research, we integrating diacritic restoration and question classification into Vietnamese question answering system. It's a public on uh, advanced in engineering and computer science journal. And here is the architecture of our model. The first, we is the diacritic restoration, and we use encoder and decoder for this start. And next, we apply the question classification, and we build application for the Department of Information and Communication. And you can check the link demo here. Yeah, and in this research, we apply diagram restoration with the question classification. Yes, and we apply in the Museum Department of Communication department. Yes, look like that. But we only apply in the information retrieval model. However, in the future, we will improve this model to get better result. That is to care about the symbol to build the chatbot by apply question classification. Um, Classification, and we do in another domain, not only in the chatbot, for example, in the sentiment analysis and document classification, uh, name entity recognition. There are many types in natural language processing. And I just present with you how to apply the deep learning to build a chatbot. You know that the deep learning offer a way to have large amount of computation and data with little engineering by hand. And various deep model have become the new state of that method for LNP problem. And supervised learning is the most popular practice in the recent deep learning research for LNP, and unsupervised method is more difficult than the other. And for the chatbot, we can apply retrieval model or generative model. From the Noam Chomsky, you do not to get discovery in the science by taking huge amount of data, throw them into a computer and doing statistical analysis of them. That's not the way you understand things. You have to have theoretical insight. Yes. Here is some reference of my presentation. Thank you.
Thank you, sir.
Do you have any question?
Yes, sir. Basically, I got this question in my mind from your example on the checkers.
Mm-hmm.
So I was trying to make one chess engine, and I tried to make the tree using the minimax, but
Mm-hmm.
somehow I'm not able to make a good algorithm which works as per the player. I mean,
Mm-hmm.
if an amateur player is playing, still
Mm-hmm.
the chess engine is going to work totally fine. So there is no chance a player can win against the computer. So, sir, is there any solution for this?
Uh, yeah, to talk about maybe related to the second our publication here. You mean that diacritic restoration? Is it right?
Yes, sir.
Yes. And with the in the Vietnamese, we in this research we apply for Vietnamese. Maybe the Indian language is very different with the Vietnamese language, and in the Vietnamese language, there are a lot of diacritic, so that however Vietnamese people usually forget this diacritic, and that's why we because you know that it's we it you input with the wrong sentence, and you can get the bad result for classification, and if you apply to restore diacritic, you can make the sentence more better. And when you input the sentence, this sentence to the model, you can get a better result for classification. Yes.
Okay. And so the alpha beta purling might help in this.
Mm-hmm. Sorry.
So doing the alpha beta purl.
Ah. Here I use encoder, decoder. If you want to see more detail, you can refer in my publication here. On my publication, I put on the research gate, and you can get the PDF version to read more detail. Okay.
Surely,
Do you have any questions?
ये नंबर कंफर्म हुआ था विवेकी, देखिए तो 48 लास्ट में जो है।
Sorry.
Any more questions?
लास्ट में 48।
It seems the participants do not have any more questions. So
Okay. Thank you.
thank you so much,
Okay.
Professor Hung. On
Okay.
behalf of ITM BU family, I convey sincere thanks to you, Professor, for being with us today and enlightening us with technicality of AI, which is actually the need of an hour. Thank you, sir, for presenting the new edge technology to us. It would inspire our students to make new innovative AI projects in future. It was a
Okay.
privilege to have you with us, sir. Thank you so much.
Thank you for your attendance today. Yeah.
Thank you so much, sir. I must mention our deep sense of appreciation for ITM BU management for providing us the opportunity to conduct such an informative session in benefit of our students. I finally thank all the attendees, the faculties, and the students for gracing these events with their presence. Thank you, everyone. So on this note, we are ending today's session. Thank you so much.
Oh, thank you very much.
Thank you, Professor Tang. Thank you.